Hello students, today we'll discuss IB Physics HL Paper 1, May 2021, Time Zone 2. In this paper you cannot use calculator. My name is Nariman Merlim. I'm located in Baku and here you can see my mobile and email. To prepare for exam, you can use main huge textbook from Oxford, short textbook by Tsokos, very popular, and for revision and better understanding, Physics Study Guide by Tim Kirk. When you do past papers, you need Physics Data Booklet, First Assessment 2016 copy. Desirable is to have IB Physics Guide 2016. Let's start. So this exam took place on Monday, 3rd of May 2021 afternoon, 1 hour. Question 1. A student measures the length L and the width W of a rectangular tabletop. What is the absolute uncertainty of the perimeter of the tabletop? Perimeter is 2 times width plus length, or 2 widths plus 2 lengths. From booklet we have subtopic 1, 2, uncertainties and errors, the following formula for absolute uncertainty. So we use this formula twice for W and twice for L, and we get choice B. The minute hand of a clock hanging on a vertical wall has length 30 centimeters. The minute is observed pointing at 12 and then again 30 minutes later when the minute hand is pointing at 6. So it was pointing at 12 and then pointing at 6. What is the average velocity, average speed on the minute hand during this interval? Point P. So velocity is displacement over time. Displacement here is from initial point to final point, 2r, 2 radiuses, and we should divide by time to find velocity. So velocity displacement over time, we get 2 centimeters per minute. Distance it goes around, so distance is half circumference, so pi r. So we put pi r and we divide by time. So r is 30 centimeters times 30 meters. We get choice A. A block rests on rough horizontal plane. A force P is applied to the block and the block moves to the right. There is a coefficient of friction giving rise to frictional force between the block and the plane. The force P is doubled. Will mu d and F be unchanged or greater? So when object is moving, friction force is given by this formula from subtopic 2.2, and coefficient doesn't depend on speed. So object moves, we have friction force, dynamic coefficient of friction, and R is reaction which doesn't change. So unchanged, choice A. A projectile is launched at an angle above the horizontal with horizontal component of velocity vh and vertical component vv. E resistance negligible. Which graph shows the variation with time of v horizontal and v verticals? In horizontal direction we have no force, so we should have constant velocity, but in vertical direction we have force downward. So velocity will be decreasing at constant speed, which is gradient of this graph is g, so choice D. A person with weight 600 newtons stand on a scale in an elevator. What is acceleration of when the scale reaches 900? So scale shows the force of reaction. So reaction is 900 newton up. Weight is 600 newton down, so resultant force 300 up. So elevator accelerates upwards. To find how much it accelerates, we use second law of Newton, mass time acceleration equal resultant force. Resultant force we take positive direction up, so the reaction minus normal reaction minus weight. So we rewrite formula for acceleration, so weight minus normal reaction over mass. So we get 5 meters per second, positive, upwards, so choice D. Two identical blocks, each of mass m and speed v, travel toward each other on a frictionless surface. The block undergo a head-on collision. What is definitely true immediately after the collision? Total momentum before collision is 0, because there is no forces. After collision, total momentum is conserved and 0. So choice B is the best answer. The graph shows the variation with distance of horizontal force acting on an object. The object initially at rest moves horizontally through a distance of 50 meters. So this is a graph. So from 0 to 50 meters, object is moving. So object is moving all the time and reaches the mark 50 meters. So we have force working at some intervals of time. So work done by this force is area under the graph, and we have constant friction force that is working over this distance. A constant friction force 2 Newton opposes the motion. What's the final kinetic energy of the object after it has moved 30 meters? So kinetic energy will be work done by pulling force minus work done by friction. Work done by friction is friction force times total distance, 50 meters. Work done by pulling force from area under the graph, 3 triangles. So area of 3 triangles minus friction force by distance give us 500 joules, which is choice B. A sample of oxygen gas with a volume 3 meter cube is at 100 degrees Celsius. The gas is heated so that it expands at constant pressure to final volume of 6 meters. What is the final temperature of the gas? So given information, initial volume, temperature we change into Kelvin. So subtopic 3.2, modeling a gas, so we have gas equation. If volume increased 2 times, here it increased 2 times. Temperature should also increase 2 times, so it increased to this Kelvin temperature. Subtracting 273 give us degrees in Celsius, so choice B. Two identical containers, X and Y, each contain an ideal gas. X has n molecules of gas at an absolute temperature of capital T, and Y has 3 n molecules of gas at an absolute temperature of T over 2. What is the ratio of pressures? Py over Px. So identical containers means the volumes are the same. Subtopic 3.2, modeling a gas. So we have gas equation, and n is number of moles. So number of molecules divided by Avogadro number will give us number of moles. For Y gas, we write this equation. For X gas, we write this equation, dividing both sides, left and right side of equation of 1 and 2. And after simplifying, we get the ratio is 3 over 2, choice C. A piece of metal at temperature 100 degrees Celsius is dropped into an equal mass of water at a temperature of 15 degrees Celsius in a container of negligible mass. The specific heat capacity of water is 4 times that of metal. What is the final temperature of the mixture? Heat leaving metal equals heat entering water. So subtopic 3.1, thermal concepts. So thermal energy when object is heated is given by this formula. Rewriting this formula for rewriting equation 1 with equation 2, so we substitute for heat and heat, we substitute the expressions. Change of temperature, so piece of metal temperature decrease from 100 to T, and water increase from 15 to T. So after solving this, after simplifying by C metal and mass, we get formula for capital T, and it is 32 degrees Celsius, so choice D. The bob of pendulum has initial displacement x0 to the right. The bob is released and allowed to oscillate. The graph shows how the displacement varies with time. At which point is the velocity of the bob at maximum magnitude directed towards the left? So right direction is positive, left is negative. So we need negative velocity. Method 1, so we know that velocity equals gradient of time, so of displacement. Displacement is cosine function. It means that for graph of velocity will be minus sine function, and negative, maximum negative, is at point C. Another method is to use gradient, so maximum negative gradient is at point C, so choice C. Here we have difference from mark scheme. I think that in mark scheme they made mistake because this is easy question. Which graph shows variation of amplitude with intensity? In the booklet we have formula linking intensity with square, so intensity is proportional square of amplitude. It means that amplitude is proportional to square of intensity. So graph A is the answer. Unpolarized light of intensity I1 is incident on a polarizer. The light passes through the polarizer, then passes through the second polarizer. The second polarizer can be rotated to vary intensity of the emerging light. What is the maximum value of the intensity emerging from the second polarizer? After first polarizer, intensity decreases 2 times. Second polarizer has no effect if it is parallel to the first polarizer. So we get choice B. The frequency of first harmonic in a pipe is measured, and an adjustment is then made which causes the speed of sound in the pipe to increase. What is true for the frequency and the wavelength of the first harmonic when the speed of sound was increased? Wavelengths unchanged as geometry of pipe not change. Hence frequency will accordingly to booklet 4.2 traveling waves wave equation we rewrite for frequency. So as speed increases, frequency increases. So wavelength unchanged, frequency increases. Choice A. The diagram shows two cylindrical wires X and Y. The wire X has a length L, diameter D, and a resistivity ρ. Wire Y has a length 2L, diameter of D over 2, and resistivity over 2. What is ratio of resistance of X to resistance of Y? So subtopic 5.2, we have formula for resistivity. We write for this formula for resistance. Write this formula for X and Y, then find the ratio and simplify. So we instead of ratio of two resistance, we have ratios of resistances, lengths, and areas. Okay, so because diameter decreased 2 times, the ratio will be 1 over 4. So we get choice D. So resistivity of R is of R is 2 times more than Ry. Length of X is 1 over 2 ratio and ratio of Y over X is 1 over 4. So we get 0.25, sorry, here mistake. Choice D. Right, 16. Question 16. An ion moves in a circle in a uniform magnetic field. Which single change would increase the radius of the circular path? So, a formula for force formulas for centripetal force from booklet. They're equal. So rewriting for radius, we see that to increase the radius, we can only increase the mass. The rest choices: decrease speed, no, because proportional to speed. Increase charge, no, because inversely proportional. Increase the mass, yes, and increase the strength, no, because increasing strength will decrease radius. So our choice is C. A circuit containing a variable resistor of maximum resistance R and fixed resistor also of resistance R connecting a series. The EMF of the 6 volt and its internal resistance is negligible. What are initial and final voltmeter reading when the variable resistor is increased from an initial resistance of 0 to final resistance? So we have potential divider. Output, for example, if we take as output variable resistor, output is first 0 and then it is half of, it is 3 volt, but we take reading from fixed resistor. So as a result, when this is 0, this is 6, and when this is 3, this is 3. So from 6 to 3, choice C. Here I use formula not in booklet, so you can use output, for example, R1, or actually R2 also can take R2, doesn't matter. Magnetic field lines are an example of a model to aid in visualization. So choice B is the best choice here. Question 19. An object moves in a circle at constant radius. Values of centripetal force are measured for different values of angular velocity. A graph is plotted with omega on the axis. Which quantity plotted on the y-axis will produce a straight line? So we have this formula for circular motion. Taking square root of both sides, we see that we have direct proportion, hence straight line, and on y-axis we have one quantity, square root of f, and another quantity is omega. Mr is constant. Choice A. Question 20. A sample of pure radioactive nuclide initially contains N0 atoms. The initial activity of sample is A0. A second sample of same nuclide initially contains 2 N0 atoms. What is the activity of the second sample after 3 half-lives? Second sample has initial activity 2 times more because 2 times more radioactive atoms. After 3 half-lives, activity is decreased by 2 to the third, 8 times, and becomes 4 times of the A0. Force of A0, so it is choice B. Question 21. Question 21. The diagram below shows 4 energy levels for the atoms of a gas. The diagram is drawn to scale. The wavelengths of the photons emitted by energy transition between levels are shown. What are wavelengths of spectral lines emitted by the gas in order of decreasing frequency? So subtopic 7.1 give us wavelengths linked to energy. So we see that they are inversely proportional. So we need wavelengths in order of decreasing order. So the biggest wavelength is 4, then 1, then 2, then 3. And energy will be increasing. So it is choice B. Choice B. During nuclear fission, fission is division of nucleus X into nucleus Y and nucleus Z, energy is released. The binding energy per nucleus of X, Y are Bx, By, and Bz respectively. What is true about binding energy per nucleon of X, Y, and Z? So if we recall this diagram, So binding energy of X is less than binding energy of Y and Z, so we choose choice A. I want to tell you that here is confusion and binding energy is negative. This is why extra energy is released. Question 23. Consider the Feynman diagram below. What is exchange particle X? Actually, when we have two antiparticles, electron and positron, they meet and annihilate, producing photons. Then photon changes into two other antiparticles. So this is photon. What is the main role of carbon dioxide in greenhouse effect? So best choice is B. It absorbs outgoing radiation from Earth. A model of an ideal wind turbine with blade length L0 is designed to produce a power P when the average speed is V. A second ideal wind turbine is designed to produce power P over 2 with average wind speed is V over 2. What is the blade length of the second turbine? From subtopic 8.1, we have formula for power of turbine, wind turbine. A is area of circle made by blades. Rho is density, V is speed. So first turbine we have formula. So another turbine is P over 2, which means that our first turbine divided by 2, or the same, we write formula for second turbine, not knowing blades X length, but knowing that speed is V over 2. After simplification, we get X equals 2L, so choice C. Question 26. A mass spring system oscillates vertically with period T at the surface of the Earth. Gravitational field strength at the surface of mass is 0.3 G. What is the period of the same mass spring on the surface of Earth? With a formula from booklet tell us that it doesn't depend on G, so the same period. C, choice C. Choice C. Question 27, just a moment. Light passes through diffraction grating. Which quantity must be decreased to improve the resolution of diffraction grating? From booklet we have formula for resolution. We see that resolution is proportional to number of order number and number of illuminated slits. But it's not the case, so we observe C and A. C is very bad, so to improve resolution, of course, you should not decrease number of grating lines per millimeter, but you can decrease grating spacing, so bending will be more, resolution will be more, so choice A. This is not quite standard question, but what can we do? Question 28. A train is moving in a straight line away from a station observer when the train horn emits a sound of frequency f0. The speed of the train is 0.10 v, where v is speed of the sound. What is the frequency of the horn as heard by the observer? So moving source, and it is moving away, so frequency should decrease by relative increase of speed, so relative speed of observer and train. So we use 0.1 plus 1 over 1, so choice B. Question 30. Monochromatic light of wavelength lambda passes through a single slit of width B and produces diffraction pattern on a screen. Which combination of changes B and lambda will cause greatest decrease in the width of the central maximum? So the size of central maximum is given by position of the minimum from data booklet. So angle is given lambda over b. So this we should decrease, so we should make angle theta as small as possible. So this we can do by decreasing lambda and increasing b. So choice C is the best. Here I show calculation what happens, and we see that decreased, it is the most decreased it is at C. No change at A and D, increase at B, and so on. Okay. Question 30. An object of mass m released from rest near the surface of a planet has an initial acceleration z. What is gravitational field strength near the surface of the planet? Gravitational field strength is force over mass. At the same time, acceleration is force over mass. So we see that they are equal. So our choice A is the choice. Question 31. The points x and y are in uniform electric field of strength E. The distance of x is x and the distance of y is y. What is the magnitude of the change in electric potential between x and y? Change of potential equals to the work done in moving object from x to y. So we can move from x to 0 and then from 0 to y. When we move from x to 0, we have force equals to intensity because charge is 1, and work equals force times distance, so work equals Ex. When we move at 90 degrees to the field, no work is done in the direction of field, so work is 0. So as a result, the total work done equals Ex, so choice A. Question 32. A satellite orbits planet X with speed Vx at distance r from the center of this planet X. Another satellite orbits Y at speed Vy at distance r. The mass of planet X is m, the mass of planet Y is 4m. What is the ratio? Okay. So from booklet we use orbital speed. We write it for X and for Vy. Mass for Vy we take 4m. And then we understand that Vy equals 2Vx, yes, which means that Vx over Vy equals 0.5, choice B. Question 33. A parallel plane capacitor is connected to a cell of a constant EMF. The capacitor plates are then moved closer together without disconnecting the cell. What are the changes in the capacitance and the energy stored in the capacitance? So from subtopic 11.3 we have formula for capacitance and energy of capacitor. So from the first formula we realize that when distance decrease, capacity increase. From the second we see that as capacitors increase, energy also increases. So answer is choice A. Question 34. The graph shows the variation of an alternating current with time in a 4 ohm resistor. So sine function. What is the average power dissipated? So we have peak values here. Alternating current peak value is 2 amperes. If we multiply by resistance, we'll get peak voltage. And from subtopic 11.2, we have formula for average power. 1 over 2 maximum peak value by peak value. So we get choice B. Question 35. A magnet connected to a spring oscillates above a solenoid with 240 turn coil as shown. The graph below shows the variation with time of the EMF across the solenoid with the period t of the system shown. So we have some period. The spring is replaced with one that allows the magnet to oscillate with a higher frequency. Which graph shows new variation with time of the current in the resistor for this new setup? So higher frequency and greater current and EMF should be observed. So higher frequency is here, and we have less period, means higher frequency. So choice A is best choice here. Question 36. A capacitor is charged with a constant current I. The graph shows the variation of potential difference across the capacitor with time. Gradient of the graph is G. What is the capacitance of the capacitor? So change of charge with time is given by I delta T. At any time from the graph, change of voltage by change of time equals G. So change of voltage equals G delta T. Capacitance is change of charge by change of voltage. We divide and simplify time, here time, and we get I over G, choice A. Just mathematical demonstration. Question 37. A particle of energy is incident on a barrier and has a certain probability of quantum tunneling through the barrier. Assuming E remains constant, which combination of changes in particle mass and barrier length will increase the probability of particle tunneling through the barrier? No standard question, as mass of particle is involved. Tunneling takes place due to wave behavior of particle with wavelengths. Not in booklet, the de Broglie wavelength is inversely proportional to mass. So smaller mass, greater wavelength. So mass should be small, plus width of barrier should be small. So choice A. Question 38. Element X has nuclear number AX and density Rx, ρx. Element Y has nuclear number of 2AX. What is the estimate of the nuclear density of Y? So method Y, nuclear density doesn't depend on atomic number. So answer is B. Second, with proof, density is mass over volume. Mass is unified mass by atomic number, because atomic number is number of protons and neutrons. So radius of nucleus is given by subtopic 12.2. Volume is sphere, so we find density, and we see that it is constant, doesn't depend on atomic mass. So choice B. Question 39. What is the Bohr model for the hydrogen atom? True for Bohr model. So actually it is quantization of angular momentum. So choice A. Question 40. An electron of non-relativistic speed interacts with an atom. All energy of the electron is transferred to an emitted photon of frequency f. Electron of speed 2v now interacts with the same atom, and all its energy is transmitted to second. What is the frequency of the second photon? So subtopic 7.1 gives us energy of photon. Also we know energy of kinetic energy of the particle, here electron. So for particle X we have this relation, so energy of kinetic energy changed into energy of photon, and for particle Y we have this relation. So comparing this expression, we understand that it is choice D, so 4 times increased. Here we finish. I wish you good luck. See you next time.